Good afternoon, everyone. In today's video, I want to share with us the reason scientists could not unify quantum mechanics to classical mechanics for decades. Before I proceed, I want to share two scenarios or two situations with you. The first one is a situation where we have an object at event horizon. Outside observer will observe that object as being static, but in real sense, the object will not experience any delay, let alone to experience any stoppage while entering into the black hole. Then the second scenario is a situation where we have observer observing an object that is moving away from him at the walking pace. So it will get to a point that the observer will not see the object because the object will be out of sight. So if such observer can instantly disconnect himself from his standing position to the location of the object, the observer will still see the object. So the two scenarios are pointing to spontaneous symmetry breaking, and that is telling us that there must be a kind of instance that can connect quantum mechanics to classical mechanics. So scientists have been using Schrödinger wave equation, and then they use a Planck constant, to dissect quantum mechanics in order to get reality. And so from what I said, we know that experience, which is to explore quantum mechanics by contact, is delusional, but not at classical level. Then at classical level, observation is delusional, but not at quantum level. So you can see that connectivity between quantum mechanics and classical mechanics. So now let's use this time energy wave model to illustrate it further. Now this vertical line is the solution of formula of everything, and that represents the instancy of time trajectory. So the trajectory has to come from the classical realm. This region is the classical realm. It comes down. By coming from the classical realm, it has enough energy to break the spontaneous to break this quantum suspension. And here we have spontaneous symmetry breaking that will connect us to the real mass worth of positron here.